So today we are going to do the polar graphs. Now I have this stuff written on the board and you can see it right behind me, but for anybody that's absent, they can't see that in the room. So I'm just going to write it on the paper as well. Here's our two conversions. And again, you guys can see it right behind me, but for anyone that's absent and is going to watch the video, I just want them to have this as well. So for each of these, we're going to draw the graph and convert it to rectangular form. Now, when you just have R equals, it's going to be a circle, and this is the radius. If just R equals that amount, you always want to be that amount away from the pole, so 2 units away. You did this in geometry, you just might not remember. Or, well, actually, isn't geometry the class where you got cut off at the end? Do you remember learning about circles? Did that happen before COVID hit? No. Okay, well, today is that day. You're going to get to learn it. So we're going to be centered at the pole. You're going to go 2 units in each direction. And then you're going to try to connect it and make it look circular. But I'm not here to grade your art skills, just like do your best. But if R is 2, radius is 2, you just get a circle 2 units away from the pole. Now, to convert it to rectangular form, that means you need to have an X and a Y in your answer. Rectangular would have the X and the Y. So we're going to use this right here. It's just your Pythagorean theorem. X squared plus Y squared equals R squared. Now that would be 2 squared, which would just be 4. And that's it. Now, if you're like, hey, Ms. Cole, shouldn't it be Y equals though? Not in this case. These aren't functions. They're not most of them are not going to pass the vertical line test. So they're polar equations or polar graphs, but they're not polar functions. They aren't functions. So this one, radius is 5. You're just going to go 5 units away from the pole in each direction, and then just make an attempt to draw it looking circular. They usually don't look like circles, though. They usually look like lopsided oranges or something. Just do your best. Try to not make it look like a square, but you know, whatever. You know, you'd think like, oh, drawing a circle, that doesn't sound all that hard, but it's like harder than you think to draw a nice looking circle. All right, and then what would this equation be? You get X squared plus Y squared equals 5 squared, which is 25. So if it's just R equals a number, it's just going to be a circle. Now, if you have theta equals, this is going to be a line. We just need to figure out what the slope is. Do you remember rise over run? Like you go up a certain amount and over a certain amount? For this one, we're going to use this conversion. Tangent of theta equals y over x. So this one, it's going to be tangent of pi over 4 equals y over x. And then we have to evaluate tangent of pi over 4. If you want to draw a triangle, that's fine. At this point, I'm not going to make you do that though, because we're sort of past that. What is tangent of pi over 4? Imagine the pi over 4 triangle, and then tangent is y over x. Good, it's the square root of 2 over 2 triangle, but anything over itself is 1. So this is 1. And then in this case, I would try to get y by itself because it would be easier to graph if you have y equals. So how would you get y by itself? Multiply the x. So you get y equals 1x. I'm going to leave the 1 in there just because that represents our slope. And so when you go to graph that, you're going to go through the origin, or the pole, I should call it, and your slope is 1. So up 1 over 1. So it's just going to look like this. So we're going to try that again. It's going to be a line. We just need to figure out what the slope is. We're going to use this conversion right here. Tangent of theta equals y over x. So tangent pi over 3 equals y over x. And then we just need to evaluate this. So let's imagine the pi over 3 triangle. What goes across from the pi over 3? Square root of 3 over 2, and then the other side, 1/2. So this would be square root of 3/2 over 1/2. And we're going to simplify that down. So what happens with that? If 2's cancel, it'll just be square root of 3 equals y over x. And just like we did over here, let's get y by itself because it'll just look a little bit more familiar to us. We'll multiply over the x. And so we have y equals square root of 3 times x. So it is the exact same thing as this, except the slope is square root of 3. You just get it as close as you can. Square root of 3 is like in between 1 and 2. If you want a really specific answer here, I'll type it in. Square root of 3 is 1.7 and then more numbers. 1.732050808, okay? 1.7. We're gonna start at the origin and you go up 1.7 and then over 1. So like about there. And then just like keep that going, like up another 1.7, you know, like it's not going to be perfect, but good enough. So it just should be a little bit steeper than that one. If this has a slope of 1 and this has a slope of 1.7, this should be like a little bit steeper. So just to recap, if your equation is r equals, it's going to be a circle. That's the radius. If your equation is theta equals, it's going to be a line. You just need to figure out what the slope is. Cool so far? Because these ones we have r in terms of another function, one of your trig functions. So for these, we're going to use these two. This x equals r cosine theta and y equals r sine theta. For this one, I'm going to use x equals r times cosine theta. But what is r? Secant theta. So it will be secant theta times cosine theta. It's x equals r cosine theta. It's just this is r. And then we want to simplify that down a little bit. What can we replace secant with? I know you're like, I thought we were done with these identities, but this is a simple one. What can you replace secant with? Good. See, okay, perfect. You're all brilliant. 1 over cosine times cosine. And so what's going to happen there? Yeah, they cancel. You just get x equals 1. So then here becomes the question, how do you graph x equals 1? Yeah, it's just a vertical line at 1. So you go to 1 on the x-axis, and it's, do you remember Hoy-Vux, horizontal, y equals vertical, x equals, okay, cool. So this one, we're going to do the same thing, but I'm going to use this, y equals r sine theta. So y equals r, which is this, times sine theta. And then where can we go from there? Because you want to do a similar thing to what we just did. Four times, and then we'll replace cosecant with 1 over sine. So that the sines cancel, and we get y equals 4. So what is that going to look like? Horizontal line at 4. So go to 4 on your y-axis and draw a horizontal line. Go ahead. Oh yeah, I was just going to recap that. So if it's r equals, it's a circle. That's your radius. If it's theta equals, it's a line. You just have to figure out what the slope is. You would use your tangent of theta equals y over x. And if it has a secant or a cosecant, then you use these, and it's either going to be a horizontal or a vertical line. It will cancel out. So those are like the 3 options or ways that it can turn. All right, so now we're going to do the graphs, and these look really cool, and you get a calculator for it. So you like can't mess it up. You're just going to type it in the calculator, put it on your paper. But you need to listen when I tell you what buttons to press. So I'm going to zoom in here. We're all going to go to mode. Do you see mode right here? It's next to second. Just go ahead and close the Chromebook for me. Okay. But you go to mode. You need to be in radian mode. This is a switch from earlier this year. Okay. Please make sure it says radian. Radian is the default. Like if you clear the memory of the calculator, it will put it back in radian. So it should be in radian, but if it's not, just go ahead and put it in radian mode. Okay, now we're going to go down And do you see the fourth one down, how function is highlighted? You've never left the world of function. Everything has always been y equals for you. But do you see how 2 over from that, it says POL? That stands for polar, and you're going to need to put it in polar mode. So go over and hit enter, and it'll change it to polar. Is everyone okay? Speak up if you're not, because if you can't get that changed, you're not going to be able to do anything else, okay? All right, so we're all in polar. Now you're going to hit y equals, but it's not going to say y anymore. What does it say? Ooh, r equals. That's so cool. Okay, so look, here's the first one. And this is lemacons, I don't know how you want to pronounce that. But this is the form that they take. R equals a plus or minus b cosine theta, or r equals a plus or minus b sine theta. So do you see how this follows that format? It's 2 plus 2 cosine theta. That's what you're going to type in. When you get to the theta, do you remember how you've always typed this button for x, your variable key? Did you ever wonder why it had x, comma, t, comma, theta? Because for the other modes, that's what'll show up. If you hit that button, a theta will come up, okay? So you're gonna go ahead and type this in, 2 plus 2 cosine theta. And again, if you hit that x key, it's the variable key. You've just always used x because you've never left that world of functions. But welcome. Isn't that cool? This geeks me out. It's so neat. Okay, now let's all make sure we have the same window, because if we don't have the same window, it's going to look different to everybody, and I don't want everyone to get confused. So hit window. It's your second menu button right next to the y equals. Hit window. You want your theta minimum to be 0. If it's not 0, change it to 0. And you want the maximum to be 2 pi. Mine already is, but I'll just type it along with you anyway. Make that 2 pi, 2, and then pi is right above the exponent key. You have to hit second and then the little exponent key to put pi on there. So 0 to 2 pi. Now when you leave, like when you hit enter, when you leave that line, it'll change it to a decimal. That's fine. It's still 2 pi. Pi is second and then the exponent key. It's like right above it. It's in blue, so you have to hit second to make it. Okay, cool. Now you want the theta step to be 0.1. If yours is something different, change it to 0.1. And then let's make our window -5 to 5. So make your x minimum -5, maximum 5. Scale should be 1. And then do the same thing with y, -5 to 5. I'm going to write that on the board so you can see it. So theta should be 0 to 2 pi. Step should be 0.1. X should be -5 to 5. Your scale is 1, and then same thing for y. Now, I can't speak for Delta Math, and they might make it go further than 5. So you might need to change it -10 to 10 if they give you a bigger number. But in general, that's like, I made all of mine stay on -5 to 5. Okay. Hold on 1 second. Let me pause this. All right, so hit graph. And there's your graph. Isn't that cool? It looks like a sideways heart. Oh, a lily pad. My bad. Okay, anyway, you're just gonna plot that. Okay, so you've got that point at the pole, so you can put that on there. It looks like we've got points at 0, 2, and 0, -2. And like, yes, you're literally just copying this onto a paper. And then it looks like we've got a point at 4, 0. I'm still going to call it a heart. You can call it a lily pad if you want. But isn't that neat? Oh my gosh, that's so cool. I love these graphs. Now let's try the next one. Go back to y equals, except it'll say r equals. Clear that out. And you're going to type in number 8, 1 plus 2 sine theta. And then hit graph. We already have our window set up, so just hit graph. Isn't that one neat? What do you think that one looks like? A curly Q. All right, anyway, we've got points at the pole, -1, 0, +1, 0. So you can plot those. Also 0, 1, we've got a point at 0, 1, and 0, 3. So you're plotting all the like ones that you can see, like you can tell where they are. And then you're just gonna connect it. These graphs are sweet. They're just like little doodles.
Put on the calculator again. Yes.
What are you saying it looks like? Oh, like a painter's palette, like that, yeah. Yeah, an avocado. I like it. Okay, cool. So those are lemicons. Now we're gonna do the rose curves. Ooh, roses, okay? These follow the pattern R equals A cosine N theta or R equals A sine N theta. There will be N petals when N is odd. There will be double N petals when N is even. So look at this one. You see that 3 right there? 3 is odd, okay? So this one is gonna have 3 petals. Look at this one. Do you see here there's a 2 right there? 2 is even, so you double it. So how many petals will this one have? This one will have 4 petals. You're like, what on earth does she mean by petals? Well, let's type it in the calculator. Go to y equals, clear it out, and we're gonna type in this one, 4 sine 3 theta. And hit graph, and there will be 3 petals. Okay, look it. So you're gonna have a point at the pole, and then I know it's kind of smushed on the calculator screen a little bit, so it's not perfect, but each one of these petals goes 4 units away. So this is 0, -4, and then like this distance from the pole, this would be 4. Just kind of do your best, okay? Because they should all look symmetric, like they should all look the same, but it's like, I don't know, it can be difficult. Again, I'm not trying to grade your art skills, just like do your best. In Calc BC, what we do with these is we find the areas of these petals. How did drawing that go? It's like a 3-leaf clover. Put the phone away. We're almost done, right? Go to y equals, clear it out. We're gonna type this one instead. 3 cosine 2 theta. Now this one's gonna have 4 petals. And each of the petals is 3 units away from the pole. It's because of that 3 that's right there. It's like a vertical stretch by 3, sort of, if you want to think of it that way. You all got super quiet. Is that going okay? You're just concentrating on drawing it? Okay. Circles. Now I know we did circles over here. If you just have R equals, that's the radius, and that's gonna just end up being a circle. But they can also be like this, A cosine theta or R equals A sine theta. So here, let's do this one. It's gonna come out to be a circle. It might not look perfectly circular on the calculator because again, like with the pixels on the screen, it's not like perfect, but it is a circle. So go ahead and clear out. We're gonna type this one instead, 3 sine theta. And so we're gonna have points at the pole and then 0, 3. And then just try to make it look as circular as you can. And then last one, these are called lemniscates. R squared equals a squared sine 2 theta, or r squared equals a squared cosine 2 theta. When you go to type this in though, you'll notice you don't have an r squared equals. So you have to get r by itself. What do you have to do then to both sides here? Okay, so when you type it in, you're gonna type square root of all of that. So square root of 4 cosine 2 theta. Because we don't have an r squared equals, it's just r equals. So you have to get r by itself, so you have to square root. And that was cool, it kind of looks like an infinity. Do you see how it kind of goes blank there? If we were, okay, so you know how we made the step, you don't have to change this, but if you just want to watch me, you know how we made the step 0.1? It's only putting another pixel every 0.1 of a like rotation, like of the angle. Does that make sense? Like if we changed that to 0.01, it would put more pixels on and it would kind of fill that in. Is this making sense? Anyway, it kind of looks like an infinity, which is neat. So we're gonna have a point at the pole, -2, 0, and 2, 0, and it's gonna look like this. But don't stop listening because I need to go over this in case if you don't have a calculator like this at home, and I'm doing this for the benefit of the people that will end up being absent and watching this video, okay? So I'm gonna share my screen and show you how this works on Desmos if you're gonna use Desmos instead, okay? So here's Desmos. What you have to do is come up here to this little wrench. Do you see that? All right, and do you see how the grid, you have these two options? Well, change it to polar. You're gonna choose that one. Oh, cool, isn't that neat? All right, and then when you come over here, you have to type r equals whatever, and then it will work. So like here, pick one and I'll type it in. Which one do you want to do an example of? Like one of the rose ones? We'll do 3 cosine, what was it, 2 theta? And theta is if you come down here and get your alphabet, you have a theta right there. So there you go. So that's how you can do that on Desmos. You just have to go over to the little wrench, change it to polar, and if you don't type the r equals, it won't work. You have to type r equals to make that work.